Hey there, students. Welcome to part two of the midterm test review. We're going to be focusing on vectors in the following five problems we're going to do. So let's go ahead and take a look at question number six. So number six, in a warehouse, a box is being pushed up a 20-degree inclined plane with a force of 3 pounds, as shown in the figure. What is the horizontal component of the force? So remember your resolution of forces into its components, breaking down forces into its components. Let's write down some formulas. We have two components, the vertical and the horizontal. Um, the vertical component is a component that's opposite the angle, and you remember in SOHCAHTOA, the one that relates the opposite and the hypotenuse is sine. So the vertical component, I'm going to call it f of y, um, is basically f sine theta. Okay? So let me draw a graph of the situation so that you can understand what I'm talking about. So let's say you have a force acting at an angle. This is the horizontal component of the force, and this is the vertical component of the force. Okay, I'm gonna draw it here, but it's the same thing. So this is the angle theta right here. The hypotenuse is basically the force. Okay, the magnitude of the force to be exact. So this is the force right here, and this is the vertical component of the force, f sub y. So it's the one that relates the hypotenuse in this side, and that's sine, opposite of hypotenuse. So f sine theta is the vertical component. Okay? So the horizontal component, horizontal, is the one along the x-axis, f sub x, and that's the adjacent. Okay? This is the opposite. This is the opposite right here, and this is the adjacent. This is f sub x. So the trig ratio that relates the adjacent and the hypotenuse is this cosine, right? From ka in SOHCAHTOA. So the one we're focusing on for the vertical component and the horizontal component, f sub x, is the ka piece. Okay, so f sub x, the horizontal component, is f cosine theta. Okay, so in this problem we are asked to find just the horizontal component. So all we're looking for is this piece right here. Okay, so horizontal component, let's write it again. Horizontal component. In this case, we can clearly see that this is f. So f is equal to 3 pounds, and theta of the angle of the force from the horizontal was 20 degrees. So the horizontal component, f sub x, is equal to 3 cosine theta, which is 20 degrees. All right, so we just plug that into our calculator. So we're gonna have, let's see, you set my mode to to degrees. Make sure we're in the right mode. So f 3 cosine 20 yields 2.8191 to two decimal places is 2.82. Okay, so our answer is going to be F's the horizontal component of force is approximately 2.82 pounds. Okay, so our answer is option B. All right, let's move along to number 7. It says that u equals negative 5I minus j and v equals negative 5I plus j. Which of the following is equal to u plus 3v? So it's a linear combination of two vectors. So we have u equals negative 5I minus j, but we notice that vector v was scaled by a factor of 3. Okay, so v is negative 5I plus j. So what does that tell me? That tells me that 3v is going to be 3 times the vector v. Okay, so it's going to be 3 times negative 5I plus j. Okay, so what do I do here? I just simply distribute the 3 to the two components, the horizontal component and the vertical component. All right, here are my arrows again, horizontal and vertical components get scaled by a factor of 3. All right, so 3v is basically going to be equal to negative 15I plus 3j. Okay, so we have to find the value of u plus 3v. Okay, these are vectors. So u is negative 5I minus j, and then 3v, as we found here, is negative 15I plus 3j. Okay, so we're just going to add the i's and the j components. We're going to add them vertically. So let's go ahead and do that. Negative 5 minus 15 is negative 20. Negative 20i. And negative j plus 3 is plus 2j. Okay, negative 20i plus 2j is what is equal to u plus 3v. So our answer is option C. All right, let's move on to question number 8. It says, find the work performed when the given force F, vector F, applied to an object whose resultant motion is represented by the displacement vector d. Assuming the force is in pounds and the displacement is measured in feet, use the formula work equals the dot product of F times d. I mean, the dot product of F and d. Okay, so to look for the work done, we're going to be dotting vector F and vector d. So that's going to be, it's expressed in an ij form. So we're going to have 45i minus 12j dotted with 80i. Let's try that again. Dotted with j dotted with 80i plus 5j. Okay, so remember the formula for finding the dot product. Let's write it up here. You have ai plus bj. Let's call this, yeah, ai plus bj being dotted with ci plus dj. All you simply do here is you multiply the I components, A times C, and it's added to the J components, which is B times D. Okay? So multiply the I components like the X's, so like the X's, X1, X2, multiply the X's and then the Y's, Y1, X2, Y1, Y2. Okay, so you multiply the X's and then the Y's and then you find the sum. Alright? So that's basically how you find the alright, so let's apply that formula here. So we're going to have, it's going to become 45 times 80 plus negative 12 times 5. Okay? Alright, so if we multiply it out, we're going to have 45 times 80 is 3600. And then negative 12 times 5 is negative 60. And the difference is 3,540 foot-pound of work that's been done. So our answer is option B. All right, let's move on to question number 9. Question 9 says, find the dot product of Z1 and Z2 in standard form. So we have two vectors written in polar form. And we're asked to find the product of these two numbers. Okay. All right, so I kind of got it mixed up. This is the correct number 9. So yeah, let's do this one instead. All right, so question number 9 says, what is the dot product of these two vectors? So let's set it up. So we have 5 times 4 times 5 comma 4 comma negative 5. Right, again, 5 comma 4 comma negative 5. And we're dotting it with another 3D vector, which is negative 2 comma negative 5 times negative 1. So all you simply do here is you multiply the x's, the y's, and the z's, and then you find the sum of the products. Okay? So that's how you find dot product. So we're going to go 5 times negative 2, that's the product of the x's, plus 4 times negative 5, that's the product of the y's, plus negative 5 times negative 1, that's the product of the z's. Okay? Alright, so let's work this out. We have negative 10 minus 20 minus 1 times minus 5 is positive 1. Okay, so this equals negative 30. Actually, this is plus 5. This is plus 5 right here. Okay, so minus 30 plus 5 equals negative 25. So the answer is option D. All right, let's move on to question number 10. It says a force of 60 pounds acts on an object at an angle of 25 degrees, and the second force of 60 pounds, same magnitude, acts on the same object at an angle of negative 70 degrees. What is the magnitude and direction of the resultant force? Okay, so let's draw a coordinate system to orient our vectors relative to the same point. So let's say that, let's place our object on the origin. Okay, so this is our object, resides right here. Okay, so the first force of magnitude 60 pounds acts at an angle of 25 degrees. So let's say that's the vector right there. And then what I'm going to do is let's indicate the angle of rotation. It's going to be 25 degrees. So that's 25 degrees. Remember, when you're measuring angles, this is 0. If you go in this direction, counterclockwise is positive, okay? And then if you go clockwise, that's negative. So this is a 60-pound vector acting on this object right here at an angle of 25 degrees. The second one is the same 60-pound, is another 60-pound vector acting at negative 70 degrees. So let's go ahead and do that. So I'm just going to try and make a sketch of another vector. It should be of the same length, but let's try our best to make it look like that. And it's going to be, all right, so there goes the second vector. Let's say this is our angular rotation of negative 70 degrees. So this is going down 70 degrees. Going down negative 70 degrees. Okay, so this is also 60 pounds, 60-pound vector. All right, so we have to find the resultant force. We're going to use the parallelogram method here to find out what the resultant vector looks like. Okay, so let's go ahead. We're going to translate this vector down here to the tip of the other vector, and then we're going to complete our parallelogram. Okay, so what I'm going to do is I'm going to take this vector and translate it here, make it a dotted line like that. And then I'm going to complete my parallelogram with another vectors, translating this vector up here to the tip of this vector down here. And there goes your parallelogram, okay? All right, so our resultant vector is going to be the vector that starts from the origin and ends at the tips of the two translated vectors. So this vector right here is the resultant force. Okay, that's resultant force. That's what we're looking for. The magnitude and its direction from 0 degrees, okay? All right, so let's go ahead and see what we can figure out with this information that we have. This is a parallelogram, so we know that opposite sides are parallel and congruent. So if this is 60, this side has to measure 60 also. And we know in a parallelogram that adjacent angles are supplementary, okay? So this entire angle here is 25 plus 70, which is 95 degrees. So this entire angle here, this whole angle is 95 degrees. So if this is 95 degrees, that means this angle is going to be the supplement of that angle, okay? So in order for us to be precise with our measurements, let's label everything so we know which is which. So let's call this A, and let's call this C, and let's call this B, and we can call this D. Okay? All right, so angle C and angle A are supplements, okay? They're supplements of one another. That means they add up to 180. So angle C is basically 180 degrees minus 95, okay? So if you do the calculations, you find out that angle C is 85 degrees, all right? So this is 95. This angle right here is 85. The opposite angles of parallelogram are congruent. So this is also 95. And this angle right here is 85. Okay? So what I'm going to do is I'm going to extract this triangle that I have right here, and then I'm going to solve it for this force right here. That's the magnitude. And then later I'll figure out what the angle is. All right? Let's go ahead and do that. All right, so let's just move that. Let's just extract that down here. Let's put it over here. Well, let's put it to the side so we can see what we're working with. Okay, so let's put it over there. Okay, so let's focus our attention on this triangle now. It's congruent to this triangle up here. This is A, C, B. Okay, this vector starting from A to B, that's what we're looking for. That's the resultant force. We know that this is 85 degrees, this is 60, and that is also 60. Now, what uh, formula we're going to use to figure out the length of little c? Let's see what we have. This is S, side, and this is an angle, angle, side. Just a real quick review. We know that side, side, angle, and angle, angle, side are the formulas you use for the law of sines, right? And we also know that side, 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 and side, angle, side are the formulas you use for the law of cosines, right? So in this scenario, we have side, angle, side, so we're going to be using the law of cosines. All right, the law of cosines, the only one that has a big C in it is the one with the formula of the form c squared equals a squared plus b squared minus 2ab cosine c. Okay, so let's use that to figure out the magnitude of this resultant force. So we have c squared equals 60 squared plus 60 squared minus 2 times 60 times 60 cosine big C, which is 85. All right, so let's plug that into our calculator and see what we get. Let's see, where's my calculator? There you go. Okay, so we have 60 square plus 60 square minus 2 times 60 times 60 cosine 85. Okay, and the answer is 6572.78. So let's write out 6572.48. So that's the value of c squared. So c squared equals 6572.48, which was approximately equal to that. So to get c by itself, we just simply take the square root of both sides. So root that and root that. And our final answer, C is going to be, let's see what C is. Well, to get C, we're going to take the square root of the answer we just got. So the square root of the answer is 81.07. Okay, 81.07 when rounded to 2 decimal places. Actually, it's supposed to round it to a whole number here. So it's simply going to be approximately 81 pounds. Okay, so 81 pounds is the magnitude of the vector. So answer is either A or D, can be B or C. So to find out what the direction is, what we're looking for is this angle right here. The angle, let me extend this side so we can see. The angular measure from 0 degrees, to this side right here. So what we're looking for, we mark it in blue, is this angular measure right here. How many degrees is that? Okay, so there are many ways you can do that. Well, the easiest way is to just simply use averages to figure out what that angular measure is. Okay, so I'm going to use averages to figure this out. So direction, I'm going to average the angles. So direction, I'm going to use theta average. Theta average is basically the sum of the two angles, theta 1 plus theta 2, over the number of angles, which is 3, and which is 2. Okay, so theta 1 is the 25-degree angle. The second one was negative 70. So where is the middle of these two? That's what we're looking for. When we add them up, negative 25 plus 70, we have negative 55 degrees. When you divide it by 2, you're going to get negative 22.5. So theta average is negative 22.5 degrees. So this is the direction. Okay, so our final answer is option A. So there you have it. So thanks so much for taking the time to watch this presentation. Please feel free to subscribe to my channel by clicking up here and click like if you like this video. I appreciate it. And please post a comment. Tell me what you think about this presentation. More clips coming from mathserve.com. Thanks again and have a wonderful day.